So now we're going to talk about measures of center. And a measure of center is just a value that's at the center or in the middle of a data set. Now, we're going to look at three measures of center. We're going to look at the arithmetic mean, which we're just going to refer to as the mean. We're going to look at the median, and we're also going to look at the mode of the data set. So those are the three measures of center that we're going to be looking at. Now, the first thing I want to do before we start that is look at some notation. So let's talk about notation. Okay, and the notation I want to look at is this sigma notation. This is an uppercase sigma, and in mathematics we use this to represent a sum. So whenever you see a sigma, what you will do is you will add up all the values for the variable that comes directly after the sigma. For instance, let's say we have um, the variable x, and it's actually a set of values, and we're going to call each value xi. So these are the individual values from the data set. These are the data values from the raw data set. All right, so let's say we were to use the symbol sigma. Sigma is the sum, and we were to put the xi beside it, x with a subscript of I. Well, what this means is to look at each individual data value and add them all up. So this is the sum of the data values. The sum of the data values, okay? That's how you would symbolize the sum of the data values. Now, the other two important notational things that we have to look at are n, which is the size of a sample, but that's lowercase n, that's a sample size. And we also have to look at uppercase n. And uppercase n represents the population size. They're both sizes, but one is for a sample, the other for a population. Excuse me. Okay, now the next thing we want to do is we want to look at a couple data sets and talk about mean. All right, the mean, remember we referred to the arithmetic mean, and we said we were going to refer to it now as the mean. The mean of a data set is the measure of center found by adding the data values and dividing by the total number of data values. Well, we just had that last slide. We said the data values were called xi's, and this symbol meant the sum. So we can translate that part where it says adding the data values. We can translate basically this phrase, adding the data values. This phrase we can translate into this symbol, the adding of the data values, xi. So that means add up all the data values, and I'm going to show you where the data values are in a second. And it says and dividing by the total number of data values. See that part? Dividing by the total number of data values. Well, the total number of data values is n. So we're going to be dividing by n. And depending on whether we're dealing with a sample or a population, we're going to be dividing by either lowercase n or uppercase n. And the only difference is we might have a formula with this symbol as the numerator, which is the adding of the data values. It might be divided by uppercase n or lowercase n. Let's talk about the difference here. Well, if we divide by uppercase n, then the value that we get is the sample mean. So x bar represents the sample mean. This is the sample mean. All right? And the sample mean is found by adding up all the data values adding up all the data values, adding up the xi, and then dividing it by lowercase n. When you divide by lowercase n, you're dividing by a sample size. So that's the sample mean. Now, if we take the sum of the xi's, the adding up of all the data values here, and we divide it by uppercase n instead, well, we don't get the sample mean, we get what's called the population mean. Population mean. And the population mean has a different symbol. We don't use x bar to represent the population mean. We use the Greek symbol mu to represent the population mean. It's like a M. It's a curly M, I guess. And this is what I'm going to be using to symbolize the population mean. This is what I'm going to be using to symbolize the sample mean. And the only real difference is what we call the size. It could be a sample size or a population size. So let me show you what I mean here. Let's get rid of this for a second. Now here we have two data sets. And in these data sets, what I want to do is I want to say, well, this first data set represents a sample of something. Who knows? It may be a few totals for points for a game for an NBA player. It may be anything, but it's only a sample of 1, 2, 3, 4, 5, 6, 7. So, in fact, the sample itself doesn't equal 7. Let me erase the equal sign here. The sample doesn't equal 7. In this sample, n, the sample size, is equal to 7. So this data set, just because I call the size of it n, lowercase n, represents a sample. This data set down here, I'm going to call its size n. So this is a population of things. These are all the numbers for a certain quantitative measure. And this is every single value. It could be, who knows, it could be the number of students that graduated from a small school in a given semester. It could be any number. But this would represent the population, all such numbers. Maybe the school has only been in business for, let's see, 1, 2, 3, 4, 5, 6 semesters. So we have two sizes, and I mean, really, it's an arbitrary decision. Is how you define your sample and your population, whether you call it lowercase n or uppercase n. The formulas are exactly the same. All right. So let's go ahead and actually calculate the mean for these two samples. All right. So for data set 1, in order to calculate the mean for data set 1, what I'm going to do is I'm going to take all the values, the xi, so for data set 1, right, we see that x1 is equal to 9, and x2, the second data value, is equal to 15. Then we have x3 is equal to 11. And, you can continue in this fashion. And the last x, which would be x, well, the sample size here we said was 7, remember? The size of this sample is 7. So the last data value would be x7. So we could go all the way up to x7, which is number 13. So this is the representation of the data values in data set 1 and how they would be represented with the notation xi. The I are the, I guess, order of the collection of the data, of the raw data values. This is a set of raw data. Set 2, this data, we also have x1 equaling 56 and x2 equaling 38 and It continues in that fashion all the way up to the last data value. Remember that size of that population was 6, this one here. So we go back here and we will take this all the way up to x6, which would be equal to 55. So we have all those data values. And what we want to do is in each set, we want to add up all the data values and divide by the sample or population size. So for the first data set, we're going to calculate x bar. Now, x bar is going to be equal to the sum of the xi's. Well, the sum of the xi's in this case is equal to the sum of all these xi in the data set all the way up to x7. So the sum of the xi is just the sum of all those underlying numbers. And we're going to divide by n, and since we go all the way up to x7, that means there are 7 elements in this data set. So we're going to divide by 7, which is n. Oops. Well, we're going to divide by n, which is 7 in this case. But let's write the formula here. We're dividing by n. And the sum of the xi's, well, when you add up all these numbers, you get 84. The sum of those xi's is 84. If you add up the 9 plus the 15 plus the 11 plus the 14, all the way up to the 13, you get 84. And if you divide that by n, which we just said was 7, you get that the sample mean for this first data set, x bar, is 12. 84 divided by 7 is 12. So there we found x bar for data set 1 is equal to 12. 84 divided by 7. All right, now let's move on to the next data set. All right, let's get rid of some of this here. All right, so now for the next data set, we're going to look at this data. X1 being 56, x2 being 38, x3 72, x4 is 71, x5 is 20, and x6 is 55. So we have 6 data values, and we're going to calculate for this data set, since we have n instead of uppercase n instead of lowercase n, we're going to calculate mu, which is the population mean. The population mean is the sum of the xi divided by uppercase n. So it's the sum of the xi divided by uppercase n. And what we're going to do is we're going to take all of the data values and add them up. And when we add up all the data values, we get a total of 312. That means that if I add up 56, 38, 72, 71, 20, and 55, I get 312. That's the sum of the individual data values. And we're going to divide that by uppercase n, and uppercase n is 6 in this case, so that we get mu, which is the mean of the second data set, to be 52. So you see, we calculated them in the exact same way. The only distinction between calling it x bar or calling it mu is whether the initial raw data represents a population, in which case we're using lowercase n for the size of the data set, or whether it's a population, in which case we're using uppercase n for the data set. All right.